Welcome back again to Coding Bootcamp's presentation of the Introduction to the Java Programming Language. This is session 9, and we're going to talk about the convenience by using polymorphism. And just a brief recap of what we have discussed. We discussed instantiation, we discussed inheritance, and what we're going to talk about now is closely related. So polymorphism is definitely closely related to inheritance, and we're going to see the abstract classes, which we're going to talk about. That is also closely related to inheritance, and so are interfaces. Here we're going to talk about polymorphic behavior, the concept of a signature, abstract classes and methods, final methods and classes, purposes of interfaces, using common and creating interfaces, and common interfaces of the Java API. The materials we need are just these PowerPoint slides. So polymorphism is when an object, even though it's inheriting, can take different forms. So even when a child class inherits from a parent class, we can slightly change some of the methods that we are inheriting from that parent class. And a good way to tell if there's polymorphic behavior is, does it pass the is-a test? And all Java, everything in Java is an object, and they're all polymorphic in some way. And any Java object will pass the is-a test for their own type of class object. So we can see here, a deer is an animal. So if there was an animal class, we can inherit from that. And vegetarian can inherit from animal. So a deer can also be an animal that's a vegetarian, and a deer is also an object. We can see here, again, here is our class. This will eventually be our superclass or our parent class employee, and we have encapsulation here. We have our constructor. We can see here one of the methods is mail check. Notice mail check here. Then we are toString to output some data. Get name, and then we also have get address, set address, get number. So we are here, you can see this is a pretty typical type of class that we can use and reuse. With polymorphic behavior, though, we can see here that we are extending employee. So our salary extends employee means we are inheriting from it, but we're slightly changing. So we're overriding mail check. So if we look very quickly again at mail check, we see mail check just really had this one line, whereas now we're adding a second line. So we are overriding. So salary is changing one of the methods that it's inheriting from the parent class or the superclass employee. Then there's abstract classes, and we discussed abstract classes and we looked at them in one of our exercises. So abstract classes are classes that contain abstract methods, and an abstract method is a method that's declared but it's not implemented. And so it doesn't have any curly braces. That's a fancy way of saying there's no curly braces. Abstract classes are not instantiated, but they do require subclasses to provide their implementation. And an abstract class is a class that is declared as abstract. We'll see an example. And it may or may not include abstract methods. Usually does, though. Abstract classes cannot be instantiated, but they are subclassed. And an abstract method is a method declared without an implementation, so without the curly braces, and it's just followed by a semicolon. So you can see it right here. Notice we say abstract void, which is the return move to. We could see it takes a double. It takes two doubles, but there are no curly braces, and they're just a semicolon. So if we see this here, and we took a look at this earlier, we have our abstract class. Here's our abstract method, and there are no curly braces. So here's another example. So we have an abstract class called animal, and one of the abstract methods here is make noise. And we don't, so here we don't instantiate animal, but we do here implement it, so we extend it. extend animal, and you can see here is the make noise. And notice we have two different classes that are extending animal, but their abstract method is different in each one. The dog class is saying bark, and the cow class is saying moo. Now, there could be times where we don't want our polymorphic behavior to override. There could be a method that we don't want overridden, so that's where we use the final classes. So you can declare some classes as final. The final keyword in a method declaration is used to indicate that the method cannot be overridden in the subclasses. So the object does this in a number of its methods are final. You may wish to use the final if the implementation that should not be changed because it's critical for some reason. Let's take a quick look back at our earlier example. Again, we had this parent class or superclass called employee and mail check. Notice mail check here is not final, so therefore when we extend on it, we can have this polymorphic behavior. If we used final, this type of changing mail check or overriding mail check would not be permitted. So again, coming back here, let's take a look at an example. So we can see here that with this class, we are declaring this method as final. So anything that inherits from a chess algorithm, we cannot override it. And interfaces. So interfaces are very, very closely related to abstract classes and abstract methods. So they help us define an interaction with the objects, so the real world objects. Methods in the interface are also declare which methods must be used in the class that is implementing the methods. So it makes for more consistency and a much more unified approach. So if we take a look at an interface, we can see here interface bicycle, and notice here the methods in here. We define almost a skeleton or a framework of what the interface bicycle should contain. So anytime we are implementing, so we don't inherit from interfaces, we implement them, we're going to be required to have these methods. But notice there's no curly braces, so we are permitted to add whatever logic we need for each of these methods. So let's take a look at a brief example. In this example here, we can see that we have an interface. We have declared a public interface called measure. And we can see here that we have two methods in here. And if we move over here to a class, we have a class reporter. It implements measure. And we have to have the two methods, update, my update size, and my rev. So we can see here my update size and my rev. And we can see here the return data. Let's comment out one of these and make it not compliant. Let's comment out one of these methods and make the class not compliant with the interface. And we'll save that. And notice now we're getting an error here at the top. And if we hover over here, it may be hard to see, but it's saying that the type reporter, which is our class, must implement the inherited abstract method my update size. So if we put it, so there's the error. And if we remove the comments, the comment block, and save, the error goes away. So here's an assignment. We will, and you'll have this, we'll take a brief look at it at the end of this video. So we'll see here that we'll have an abstract class called shape, and we will have some methods in it. And here we are going to then inherit from it, and we're going to add methods for converting to string and second class for circles. So we can, and we're also doing an array of shapes. So we'll declare a shape array. So we'll go over a solution for this assignment. And here is our summary. So we discussed the purpose of polymorphism, abstract classes and methods. We reviewed those. Final classes and methods, the purposes of interfaces, using and creating interfaces, and our assignment is going to take a look at interfaces in the Java API. Again, there is live coaching classes, so please take a look at your learning materials, and thank you for watching this video. Stay tuned for just a review of a possible assignment or lab solution. So let's take a look here at our, here is our shape abstract class, and with our abstract methods in here. We created a circle shape and a rectangle shape. And inside of the rectangle shape, we have our main method. And if we take a look here at circle, it says to create an array of shapes. So shape is right here. So we create this, declare the shape array up here, and then add to the shape array, we add a rectangle with its parameters, its height and width, and the circle with its radius. And then we output the different shapes. So we also calculate the area. If we take a look here, we do some area calculations of a circle, of a rectangle. So let's take a quick look at what this looks like. So we go to rectangle over here, which has the main method. We select our reporter Java class file, and we say run as rectangle, Java application, and we can see the output here where it's outputting where the shape is actually beginning, so the coordinates there. So it's listing these various, so we had we declared 4 shapes here. We could see all 4 printing out here. So take a look at the lab, and you'll have the source code.